improve different aspects of urban life, including the outdoor thermal comfort. Continuing with the facts, the cause and effects. Urbanization causes microclimate change. As you can see in the figure, the rural areas is different from the suburban, from the commercial areas, from the CBD of the city. So urbanization causes changes to the microclimate environment. Urban areas consume enormous amounts of energy. The goal of urban livability with respect to climate design is to achieve thermal human comfort for a majority of urban outdoor spaces. The main aim to prove that thermal comfort can be considered as one of the most important indicators of urban livability, also to establish a relationship between microclimate data and building geometrics using outdoor thermal comfort as an indicator, and to translate this knowledge into a parameterized design feedback tool. There are also some secondary aims. I will just escape it for the time limitation and go to the methodology. We use the steady state assessment methods, which is a very well-known method. The outdoors, actually, thermal comfort is generally studied on the urban microscale, which is affected by the canopy layer heat island and can be described and linked to microclimatic conditions by this method, the steady state assessment, as appeared in Leonardo Chen and Nigella Edwards, Outdoor Thermal Comfort and Outdoor Activities, one of the most famous studies in the field. With this information and after field measurements, a predicting process can be implemented in order to simulate how changes in urban form design details influence outdoor thermal comfort. This methodology has been a reliable data for studies in different urban climatic conditions, as stated by Cantor and Unger and Hope. Actually, in their study, they fit the psychological equivalent temperature, a universal index. So building the methodology was the very crucial part of this research. So we just divided the methodology into 4 main phases. Phase 1, building the theoretical framework that started with urbanization impact on thermal comfort, and we used the literature review to do this. And then the microclimate conditions, weather station to make this measurements, and then the potential effects on urban geometric spaces on thermal comforts, and this was like analysis study or analytical study. The second phase was to set thermal comfort variables. So we started with the environmental factors, personal factors, contributing factors, and we will go to discuss this in details after a little bit. Phase 3 is choosing a site or an urban space, outdoor space with different configuration, and then abstracting the sites in samples to know some data related to ratios, site number of the space, proportions, orientation, solid and void, and etc. This is phase 3, and phase 4, building the model, which has some calculations to be, we will go there actually, and I will explain it more, obviously. And then, so building the model, concluding the results, and getting the recommendations from the model itself. So this is the whole methodology up together. 4 phases. Each phase will deal with some certain informations to be included. So now, some questions has to be answered first. What's the human thermal comfort? And then why is thermal comfort important? And is there any relationship between thermal comfort and urban livability and urban forms? Continuing the questions, what's the psychological equivalent temperature, the PET? And what is the sky view factor, SVF, means? And other terminology that we might need it in our study, like air temperature, TA, relative humidity, RH, etc., and all of this terminology has to be set at the first of the study. Then, as we mentioned before, So the thermal comfort has three main aspects: the environmental factors, which include air temperature, air movement, humidity, radiation, whatever. And then this part will be measured by a micro meteorological measurement, as you can see, like a small or a limited weather station in the field itself. The two second steps, which is the personal factors and the contributing factors, will be measured by questionnaire survey addressing the subjects. So now we have the variables of the pet, and then we should have like a relationship between the three variables or the three factors that we are dealing with in this study: the urban livability and the index of it and its relationship with the urban forms that might be the weakness of environmental vision. Urban design strategies leads to urban heat islands. And finally, the urban form measurements we have to determine some key factors like ratios, side numbers, etc., as you can see. The hypothesis is to urban forms affect thermal comfort variables, which will affect urban livability afterwards. So now we have this urban form with its ratio, side numbers, proportion, orientation, whatever, and then we have the thermal comfort with environmental factors, contributing, etc. Both of them can individually affect the urban livability in such a way we don't know exactly, maybe in a good way, maybe in a bad way, but to be sure to control the effects of the two variables here, we have to get first the mutual effects between them first, and then try to apply it to urban livability. So now we can control the effects between thermal and the urban itself. This is a very important key factor in our study. So getting the mutual effects between the urban form and thermal comfort to have like a control way to control the urban livability or to enhance it. So first, we have to set the design key variables with its equations, like build density, site coverage, open space ratio with equations and illustrations, as you can see. And you may add whatever variables you want to add according to your goals. And then connected to the urban design key variables, the urban form geometry itself of the space. So area to perimeter ratio, compacity, which indicates the compactness of urban geometry, canyon style, etc. You can add whatever you want to add from the geometry according to your goals, and then with illustrations and equations as well. So now we have the urban and geometrical variables for the space. Now we can have like key environmental performance that could be like daylight, sky exposure, sky view factor, SVF, eye insolation, whatever, or whatever factors you want to add or key performance you want to add, you may add according to your goals. As I said, it is a theoretical study, theoretical approach that might be not in a practical way yet, but just showing the way how to do this. So now, step-by-step approach for the methodology. Select distinctive urban canyon. This is the first step. Calculate and compare outdoor thermal comfort, and then correlate the outdoor thermal comfort, and finally develop a generative method with software or a computer. So it's like a stair steps, starting from employing the psychological equivalent temperature with SPF and all the environmental data you can get, and then using the previous results for validation study, you have to insert them to Rayman model, which is like a very simple software that validate the data. And then the final stage, develop the computer software to generate such a model. Then, so now I'll go here very fast. Before measuring the PET, 3 or 5 different urban canyons area will be chosen. The meteorological data acquired, we have to measure the air temperature, RH, GR, VP, W, which is wind velocity, all of this measurements are recorded. You have to set a strategy to record your data. The next step is to compare field measurements results. And finally, the optimal settings for the model that fits the local climate and environment is then obtained. Fisheye and street photographs of each selected urban areas will be taken in order. So now we have the site. We just characterized 12 forms, as you can see here. Then we just make our measurements and build the simulation model in appropriate software. So now I will just show you this in mostly obvious one here. So now this is the site, as you can see on the right, and then from this side and from these points, you just make this measurements, and for the point and the PET, SAVF, all the data you want to add it here. Orientation of the model, abstract your building, and then assign your point of measurements. While this and the next step will be like validation of the data that you have to make it according to the optimal settings. So we use the Rayman model, Rayman software. It's a very simple one. You just enter the data, the environmental data into it, and then the meteorological data are not acquired in the surveyed areas, cannot directly represent the thermal conditions. So now this is the interface of the Rayman program. I'll just skip this one as well.
Dr. Islam, you have 2 more minutes. Just to let you know.
Okay, so the last section of the method is to generate the model itself. We used a Delphi software here. This software just gets you like hundreds of alternatives that might be used in the same site to get the optimal heights and materials and geometrics of the geometrics of the space to get the optimal size, the optimal solution. So the results, I will just how to make it. This is the model that we have used for. So from the left side, the results from urban monitoring, and from the right, results from the environmental process monitoring, and then the optimal and the good sign is the 100%, which normally cannot be reached, but the gap, the alignment gap between the monitoring sides can be controlled and manipulate according to the data you have chosen, or you want to repair the outdoor space with it. So now, conclusion, I guess you can just go through it in the presentation. So I will jump to the recommendations. We have like 3 different recommendations, one for integration, one for evaluation, and one for adaptation. Each one of them should be applied in the next studies that we will have. Thank you so much for your attention, and thank you, Dr. Alia, Dr. Wissam.
Thank you very much, Dr. Islam. Now the next presenter we have is Elena Grigorieva. Okay, I hope I pronounced it right.
Dr. Alia, can you tell me how to stop sharing, or you still?
Yeah, there's a red button.
I found
yeah.
it. Thank you.
So our next presenter is Ms. Elena. Her topic is bioclimatic assessment of outdoor thermal discomfort in the Arctic. So Elena, you can go ahead and share your screen. I will be timing you from the from the time you start presenting.
Thank you, Dr. Alia, for giving me the floor. Can you hear me?
Yes, we can hear you clearly.
Yeah. Let me share my screen. Can you see my presentation?
Yes, we can see it.
That's fine. Okay, I'm Elena Grigorieva, leading researcher from the Institute of Complex Analysis of Regional Problems, Russian Academy of Sciences, located in Azerbaijan, Russia. My main research topic is climate and human health. And today I would like to discuss with you bioclimatic assessment of outdoor thermal discomfort in the Arctic. So it's a vast area, not just small urban in microclimatic, but a vast area and macroclimatic research. So the extreme north or far north of Russia is a large part of the country located mainly north of the Arctic, but no Arctic Circle. But not only Arctic Circle determines this area. It is defined by the influence of climatic environment on people and equipment, the small number of inhabitants per 1 square kilometer, and the indicator of development of industrial and social infrastructure, and labor cost to produce a unit of production. Traditionally, people who work there have been entitled by the Russian government to higher salary than workers of other regions, which is justified by the harsh environment. As compensation for extreme conditions, they receive an additional salary called Northern Bonus, additional leave, additional disability benefits, extra retirement benefits, including lower retirement age, and housing benefits. Such compensations under the Soviet Union began under the Soviet Union and is maintained by the Russian Federation. Most of the urban population in the Russian far north is non-indigenous residents working on fly-in, fly-out method. They initially live in more southern areas and are attracted to the north by a higher salary. A relative small part of the population consists of indigenous people of the North Siberia and the Far East of the Russian Federation, which include both small numbered people, less than 50,000 people, the larger ones such as Yakutsk, Burats, Tuvais, Komi, Karelians. They usually live in rural settlements and lead a semi-nomadic lifestyle. As a result of climatic adaptation, the indigenous peoples have developed certain genetic habituations that allow them to better cope with the environment. Total area of the Russian far north is about 5.5 million square kilometers, comprising about 1/3 of the whole country. But we have another area that is named Russian far north of Russia and equivalent area, which covers about 20 million kilometers, which is 70% of total Russia. And near 10 million people live here, or near 7% of the Russian population. The largest cities, you can find here on this slide the list of the regions and the list of the main cities, those the largest. The largest in population is Surgut with near 400,000 people. Norilsk is the most northern city, and Petropavlovsk-Kamchatsky is the most southern city. The main part of the Russian far north is characterized by very low air temperatures, especially in winter, long duration of the cold period, limited lighting in the winter season due to the polar night, and widespread of permafrost. The current study aims to show the spatial differences of the harsh climates of the Russian far north expressed by bioclimatic indices of discomfort, where the influence of low temperature on human body is enhanced by strong wind and high humidity. As you can find here, temperatures at the Russian far north can be as low as -5 degrees, its annual temperature, and mean temperature in January -22, but in Sakha-Yakutia it can be as low as -40 degrees, and you can see here temperatures for Yakutsk, the capital of Sakha-Yakutia, And the lowest temperatures are noticed in Oymacon, cold pole, and the coldest permanently inhabited settlement of Earth, which the annual temperature of -16 and temperature in January -47.5. Normally, the degree of discomfort is considered depending on the complex of meteorological elements such as air temperature, wind speed and direction, humidity, cloudiness, precipitation. We have a very good example on the previous presentation using a PET as index, bioclimate index. Here we show we demonstrate the use of indices, those that are very simple in calculating, and those that use temperature, wind speed, and humidity, and those that are very common used in Russian and in former Soviet Union countries. Wind chill wet cooling index, hail wind wet cooling index, these two first indices that use energy as the unit, and net equivalent temperature and equivalent effective temperature, those that use degrees Celsius as for unit. And here's some results. Wind wet cooling index but hill indicates that almost entire area is located in severely cold zones during the winter month, with index in category of extremely discomfortable conditions. Maximum values are found in Chukotka and in Magadan, and absolutely discomfortable conditions are indicated in some settlements in the coastal areas. For example, in the Khan location in Magadan region on the shore of Okhotsk Sea, the mean winter temperature -28, but wind speed is 8 meters per second, and they give hill index near 100 units, while Oymacon, I told you before that Oymacon is cold pole, winter temperature is -40 and no wind speed, and hill index is 3 times lower than in the previous Nayakan located on the shore of the Okhotsk Sea. Another index, wind chill index, is very high at the whole area, and most severe environments are noticed in Chukotka and Magadan region, especially close to the shore of the Far Eastern Seas, Okhotsk Sea, Bering Sea, and Arctic Ocean. The same results as for estimations of hill index. And next slide, these figures gives an examples of high values of wind chill index in locales where air temperature are not very low, just higher than -20 degrees, but with a strong wind speed in January. It's on the left side, and on the right, low temperatures lower than -30 degrees, but with a very strong wind, the same in January. And we can see that discomfort can be even higher with a higher temperature due to the wind speed. And this slide shows the differences between the actual temperatures, those that are observed at the weather station, and perceived temperatures, those that adjusted for additional influence of air humidity and wind speed.
Overlying hemispherical sky that is directly
And the differences in temperature can be as high as differences can be as high as -30 degrees, but in several locations, these differences can be even 50 degrees lower than actual. So this means that perceived temperature, which is expressed by these special indices, can be really very low. And what should we do? Severe cold stress with perceived temperatures that are much lower than the real temperatures creates a feeling of cold with the threat of frostbite. The effect of cold on human body is expressed as damage to the distal parts of extremities, chills, frostbite, trauma due to cooling, changes in hormones. Even at temperatures of about 0, chill develops under the prolonged influence of cold from several days of weeks to weeks. Wet cooling occurs on a human body of workers at temperatures of minus 10 degrees and lower when being outdoors for 10 and more hours. At low temperatures, outdoor workers should use special protective clothes. To guarantee the safety of being outdoors, it is necessary to clearly plan working regime, transportation of equipment and personnel depending on the perceived outdoor temperature, providing workers with high calorific food, proper clothing, and periodic changes of clothing items. If you cannot change conditions, you should minimize the harm to human health from the effects of harsh frost weather to reduce the potential risk of loss of working capacity with the appearance or exacerbation of chronic disease. And on this slide on the left, you can find the picture of myself in a very cold morning in my native city. And as a conclusion, the Russian far north is located in an environment with very low temperatures combined with high humidity and strong wind. And the least severe conditions of cold season are observed in the inter-mountain plains protected from the wind. And despite the higher winter temperatures, areas with a strong wind speed on the coast of the Arctic and the Far East seas are characterized by increased severity throughout the whole cold season due to the aggravating effect of strong wind. The harshness of weather here can be 1.5 to 2 times higher than at the spots located inside the continent or much further north. In general, more severe conditions are observed in Chukotka and Magadan region. Even knowing the limitation of these general assumptions based on the use of climatic data and bioclimatic simulations of thermal indices, the current study can be interesting enough that it can be used in the practice of bioclimate to find favorable or less dangerous comfortable conditions when planning business other activities, including sport or recreation events. And this is the final slide. And just as a very short introduction of International Society of Biometeorology as the vice president of this society. It's an international forum that promotes those that are working on climate and influence of climate on human beings, on plants, on animals. We have several commissions. I'm part of Climate and Human Health Commission and Tourism and Recreation. Others are animal biometeorology, phenology, and students and new professionals. We have International Journal of Biometeorology and welcome you to join us. Thank you. That's fine. That's all.
Thank you very much. Thank you very much, Elena. And you were exactly on time. So thank you for that. Next, we have Farhan Atrash.
Dr. I want to emphasize and encourage everyone, if you have a question, please type it in the chat box. And if you remember the presenter name, so we have so far Islam and Elena, the second presenter, and just mention like this question for presenter number 1 or presenter number 2. And for sure, we will share it with the presenters at the end of this presentation. Thank you.
Yes, I also thank you very much, Dr. Wissam. Now we have the presenters Farah Al-Atrash and Amro Yaghi. Their topic is resilient teaching framework to produce outdoor thermal comfort and positive adaptation in public spaces, Samman. So go ahead. I will start timing you now.
Thank you very much. Can you hear me?
Yes, we can hear you clearly.
Yeah. Thank you. So my name is Farah. I'm an assistant professor at the German Jordanian University, and my colleague is Dr. Amr Yaghi from the University of Petra. Currently, I'm the head of the department. And Dr. Amr, do you want to introduce yourself?
Yeah, I'm an assistant professor at University of Petra, School of Architecture, a qualified architect, urban designer, and graduated my PhD from the University of Sheffield, England.
And I obtained my PhD from Casmo Institute of Technology, Germany. So today we will introduce our paper entitled The Resilient Teaching Framework to Produce Outdoor Thermal Comfort and Positive Adaptation in Public Spaces in Amman, Jordan. So we will start within the structure, starting with the background, theories, the aim, the findings and discussions, followed by the conclusions and limitations. So the first thing, actually, this practice-led research aims to investigate, apply, and evaluate a methodological framework to enhance the role of higher education and architectural institutions in Amman through bridging the gap between theory and practice. The paper starts by introducing the urgency of alternative pedagogical framework within the context of it. Then moves to focus on practical teaching forms that generate spaces that are thermal comfort and socially sustainable.
So I would like to highlight the necessity of conducting this research. While cities around the world are competing for investments, our cities suffer from the current new liberal practices of public institutions, whose policies regulate and control public spaces, imposing which publics can use these spaces and how. Next slide, please, Dr. Farah. And then within the Arabic region, the Arabic version, cities are taking Dubai and Qatar as their role model, and Gulf countries generally. Next slide, please. Both new liberal practices and political agendas have produced socially polarized spaces, determining what can and can't be accessed by the public. In fact, we argue in many cities, true public spaces no longer exists. So this image shows some of the new liberal policies in Amman. This is Al Abdali Boulevard, which has an entry fees at some events, excluding the poor to enter. Next slide, please. Another form of new liberal policies that exist within our city is the couples only policy, excluding young men, Ammanis, to enter the mall. Just to mention, this policy exists across all the main malls, such as Mecca Mall. Next slide. This is one of the earliest malls in the city. City Mall, Taj Mall. And there is another very common new liberal form in Amman, which is the valet parking, occupying parts of the street, which is part of the public realm. Next slide, please. This questions our roles as academics, researchers, architects, spatial practitioners in revealing and resisting those power inequalities. Next slide, please. So Freire, in Pedagogy of the Oppressed, Paulo Freire, stated that teaching can be the instrument for real change, resisting and moving away from the banking concept, which is the teacher is telling student what to do, and they have to do what they asked what the teacher asked to do, and instead empowering them to critically explore and decide what to do. And the other theory, which is by Soja in the social spatial dialectics, we considered spaces as active and not passive. They are active and moldable. So spaces can be produced through social relations. Such theories gave us motivation to design a teaching framework that can critically produce alternative spaces.
Our research introduces teaching framework, which was applied during the second semester of 2020-2021 for both postgraduate and undergraduate spatial planning, as well as architectural studio courses with a focus on sustainability. So the courses are related actually to the Department of Architecture in two universities, the German University and University of Petra in Jordan. And the projects were designed to apply gained knowledge and skills on potential locations which need sustainable development. The students were guided to understand the subject matters by appropriate lecturing techniques and learning scenarios to enhance as well the critical and creative thinking by opening discussions, giving constructive feedback, and influencing the interaction between individuals and groups. So this map shows the selected areas of interventions. Based on the methodology, the first step was to observe, survey, and evaluate different public space in the selected area in downtown Amman. The walking track was not defined to the students, so therefore each group had different tours based on their previous experiences or research about the open spaces in that area. This led to different selections or to different site selections with different urban typologies, as we can see here in the next figure. And these urban site typologies were divided into stairs, alleys, squares, commercial streets. But even that they were different typologies, they all share the same problem, let's say, which are mainly related to the lack of shaded areas and the lack of unmanaged flows for the rainwater, for drinking water and wastewater. So the streets also, they lack the furniture streets and such as the seats, lack of vegetation and greenery, and this is a main problem in Amman, that the greenery percentage is very low, and lack of handicapped accessibility. Even that this area or all these sites, they are in the downtown, and the main accessibility is the stairs. The stairs, they were not provided within the ramps and comfortable steps. So the students, they were thinking of introducing very creative solutions, such as umbrella, for example, which acts as shading devices, which also it's for water harvesting and cleaning the water, producing energy for the night lighting. So these shaded elements were designed based on occupants' movements and the behaviors based on their questionnaire surveys within the groups there and the inhabitants, as well as the commercial streets, as they were also, they designed creative solar integrated solutions. And for the unmanaged flow, they introduced systems within the integrated approach in order to the water harvesting, enhance the water harvesting, and also filtering the water. The next site was related to the University of Petra, and Professor Hamd will introduce it.
Thank you, Farah. So fourth-year urban design studio students were guided to analyze, engage, and question Abdoun Bank's neighborhood. This neighborhood is one of the most luxurious neighborhoods in Amman, in the city. Next slide, please. So students didn't only focus on analyzing the various morphological layers, such as land use, green network, transportation, and then proposed a more sustainable principles. Next slide, please. but also the main focus was towards the social spatial relations. They conducted social studies, including interviews, surveys, to understand the main issues that users in the space need. So, for instance, safety was an issue in that space that user identified, especially during the night. Therefore, students proposed sustainable principles such as passive surveillance and mixed use during the day and night. Another interesting sustainable proposition was scenario making, envisioning how different users would perform in the space in a way that will solve their problem. So for instance, the existing site didn't have any cyclist paths. So they designed cycling paths to it.
So as conclusions, proposing framework as possibilities for catalyzing change in envisioning public spaces that are lived. Such framework can empower and provoke other academics to engage with people and our everyday experiences. These strategies empower the student to solve problems through public participation in systematic planning. And we would like to mention that the collaboration between two academics from different universities in Amman constructs a community to critically co-produce alternative resilient framework that promotes for civic responsibilities.
And at the end, I want to highlight that we faced two limitations. The first one was the time limit that we've got, because we only conducted this research during one semester only. And the second one was COVID-19 pandemic that we're facing. In conducting social studies, it was one of the limitations to conduct interview and so on. Thank you for listening, and thank you, Dr. Farah, as well.
Thank you very much.
Thank
you for listening.
Thank you very much for all the speakers, and you're right on time, on track. So I will ask you all to try to open your camera. Maybe it works this time. And Dr. Wissam will be conducting the Q&A session. So go ahead, Dr. Wissam.
The camera isn't working from my side. I'm sorry to say so.
From my side as well.
Me too.
Okay, then I will try to check again with them. But until then, Dr. Wissam, go ahead and take the Q&A session. You're muted, Dr. Wissam.
Sorry. So yeah. So we will start as we in the same order for the presentations. So we start with Dr. Islam. Dr. Islam, we got about
Yes, I'm
4
here.
questions. Yep. So after the...
I read the questions. Do you want me to start to answer directly?
Yeah, sure.
Okay, just to save the time, yes. So I have this question from Dr. Saleh about why I'm selecting PET over other thermal comfort indices. Actually, as I mentioned before, this is like a theoretical approach. It's not a practical one yet, and the PET is can be measured. Actually, can you? Oh, okay, that's fine. So now I can see it.
Mm-hmm.
Okay, so the PET, actually there are different indices to measure the thermal comfort of outdoor spaces. The psychological equivalent temperature, the PET is a notable example of a steady state model that we used at the end of the study. As you know, that it's enables the PET or the PET enables to compare the internal effects of complex thermal conditions outside with personal or person-owned experience in as in indoors as well. So this is, and it's very easy to handle it. So even feeding the model, the Rayman model with the PET variables. So this is one of the things that we have chosen, the PET. But you may use, as I told you before, it's like a theoretical approach. But just set the goals and use whatever thermal comfort indices you want to use. And just insert them into your methodology as we have done here. So the other thing is the certainty of the microclimate device. It's not practical yet. It will be a practical study in a few months. I hope so. So by then we can just measure the uncertainty of the microclimate device that we are using. There is different methodologies to measure this, even with the Rayman model that predicts the temperature over time. The other one is about the social aspects and surveys. Actually, we haven't applied, or the methodology misses these social aspects because it's just concentrating on the environmental aspects. So maybe in the practical application of the methodology, we can just do this. Another about the summer and spring, the different scenarios, seasonal scenarios. I just skip it in the presentation. It is there, but actually we have to measure the temperature or the PET over seasons, in humid seasons and dry season, the hot, humid, hot, dry. And if we have more seasons, yes, that's fine. We have to apply them on different scenarios. This is from Dr. Farah. And from Dr. Wissam, what is the difference between sky exposure factor and sky view factor? Actually, it's from the definition. You know, the sky exposure factor is the percentage of the overlaying hemispherical sky that is directly visible from a given point or set of points that the methodology, our methodology is offering. No, so this is like an equivalent to a geometric solid angle calculation or ray tracing calculation from points. While the sky view factor represents the ratio at a point in a space between the visible sky and hemispherical or the hemisphere centered over the analyzed location, as we mentioned in the abstracting the model. And then at the point where the SVF is 0, so the entire sky is blocked from view by obstacles. So this is the main thing. So sky exposure factor and sky view factors maybe are near to each other in definitions, but it's very different when you apply it and see exactly how much of sky or the light rays come into the ground floor between the buildings, which is the main items here. So why selecting PET? Yes, we have answered this. And finally, is there any other research methodology if you want to conduct the same study? Maybe not. I cannot follow this question actually, but as I told you, and I'm repeating myself again, this is a theoretical approach that you can add or remove items from the methodology according to the goals you have set. How the social aspects and survey? No, we haven't. Unfortunately, did you choose different seasonal? Yes, we have.
Yeah.
Okay, that's fine. I take more than.
Yeah.
Thank you.
Anyone of the attendance here has
Dr. Wissam, it would be useful if you ask the question directed to the speakers themselves, one by one. So that would be helpful for them to answer.
Okay, so anyone has other question for Dr. Islam?
Me, can I ask? Yeah.
Sure.
Yeah, okay. Dr. Sam, thank you for your presentation. I wonder, what do you mean by you would include when you address the question about the social aspect? you've mentioned that you might revise the methodology, if I understood you correctly, right?
Yes, yes.
But how would you engage that with the calculations? I mean, I find it really difficult to...
Actually, we haven't applied the social aspects in our theoretical approach. We just concentrate on the thermal comfort as like environmental factors. But for the social aspects, actually, to be honest, I have no idea about it now. But as I said, the methodology is a flexible one that can be altered according to the goals you have set. But in this special particular study that we have here, we just concentrate on the thermal comfort with its environmental factors.
Mm-hmm. All right, thank you.
Thank you very much for that. Thank you.
Dr. Wissam, if you can just pick up another question and address it to the one of the presenters.
Yeah, sure. So just I'm giving time to the attendants if they have any question for Dr. Islam before I open the other file. So the second or the other question that I have now for Dr. Elena.
Yeah, I'm here.
Are you? Yep. So the question that we have for you, the air temperature lower than minus 30 degree and the wind speed has less than 2 meters per second has high correlation. So the question, can you please explain the reasons? So why the correlation?
It's just the characteristics of the climate. Climate, let's say in Yakutia, it's a very continental climate with almost no wind speed and very high radiation activity. That means radiative outcome from the ground surface, which means that air temperature can be really very, very low. Let's say minus 55, it's just ordinary temperature. But in this case, wind speed is almost zero. So it's really these spots in these locations that has these characteristics. It's just a characteristic of climate.
Mm-hmm. Thank you, Elena, for your explanation. So also we are opening the door for any question.
I can find another question here about recommended recommendations for buildings design in such extremely cold conditions. As I would say that the best recommendation would be those traditional buildings, yurts, yaranga, chum, those that people, native people that are living here use, but we cannot use them. We use those buildings with thick walls and small windows that are easier to heat inside. And the most important is have a heating system that is working pretty good. That's the main what we need in this harsh environment.
Thank you so much.
I have a question, if I may.
Yeah, sure. Just introduce yourself.
Yeah, I'm Dr. Amro. Thank you, Elena, for your presentation. I wonder if you looked at the other extreme, like you're looking at really extremely cold conditions, yeah? If the solutions might overlap for the other extreme, for a really warm, hot conditions.
Yeah, thank you very much for your question. The problem with our region is that I showed you just cold extremes. At the same spots in summer, you can find the temperatures that can be as high as 40 degrees, plus 40 degrees. At the same spots, just winter minus 55 and summer plus 40 degrees. So people should adjust to both very hot temperatures and very low temperatures. So just in this presentation, I showed only cold extremes, and we can use, actually these indices can be used for both hot extremes and cold extremes. Yes, thank you. Just this presentation is only about cold.
Thank you, Dr. Elena.
That's great question and nice explanation, Elena.
Dr. Wissam, there is a question for Dr. Amru and Farah, so if you can read that out.
Yep. So, I cannot see it.
No, it's a comment. It's not a question.
Yeah. So I have another question just for Dr. Amr and Dr. Farah. In your study, did you find any correlation or discover the relation between the what you studied, the thermal comfort and positive adaptation? And you mentioned a little bit about the biking. In general, if we can talk about the transportation.
Right. If I may answer the question, Dr. Farah.
Sure.
Yeah.
Sure. Yeah.
Okay. So basically, our focus was to address sustainability in general. It's like not only environmental sustainability, but also with the focus on the social sustainability. So we designed modules for students, fourth-year students at the University of Petra and master students at the German Jordanian University. So we can't be that specific for students to address such an issue, but it would be interesting within the time limit that we've got. It's only one semester. That's all what we conducted. But it would be very interesting in future research to conduct, to address such questions, a more precise aspects to do so. I don't know, Dr. Farah, if you want to add anything or elaborate.
Actually, no. Thank you, Dr. Amr. But yes, we were looking towards the framework in order to enhance it in the future and how to develop it during the next courses. And yeah, hopefully it should be our hypothesis to have a positive correlation between these two factors. Yeah, in the coming future.
So we're trying to establish a platform between both universities, and all of you are invited actually to establish to join us, to establish such collaboration with us.
Yeah.
Thank you all presenter, and now the floor for you again, Dr. Alia.
Thank you very much. Thank you for the presenters, and thank you for the attendees for very insightful questions and interaction. So we are finishing off our session today exactly on time, 5:50. So this was very great, and thank you for the presenters for starting and ending your presentation in a timely manner. So thank you all and have a great day. Hope to see you again for tomorrow's sessions.
Thank you, Dr. Alia. Thank you, everyone.
Yeah.
Thank you.
Thank you. Thank you all.
Thank you. Bye-bye.